2A yellow class. Today is Tuesday, April the 18th. Taxes are due today, so if you haven't done your taxes, make sure you get that in. Your taxes pay me. That's how public school teachers get paid. In any case, hey, my neighbor, get ready to highlight. Grab a highlight if you don't have one there. My neighbor owes 30,000. This owes 30,000 is actually going to wind up being important in some of the earlier problems. So I'm going backwards. At this point, I've explained to you how to find the A, the B, and the X. I taught you how to change the percent into a decimal and add that 1 in front. Same thing from the cow problem, which you will get to do the cow problem one last time. I explained to you how to draw the picture of the airplane flying through the wall, hits the y-intercept. Again, for those who like, that's it. Like, yeah, so basically you're about to get like a free standard. At the very end, they'll ask this question: the y-intercept. When you drew that airplane and you said A was equal to whatever, like, what does that mean? Like, what does it mean in the context of the problem? One of them they ask about flies. There are 100 flies, and then they start growing. Another one, of course, the cow has the E. coli bacteria, and it starts growing. This one happens to be about owing money for the brand new car he bought last year. The interest, I want you to circle that interest again. If you're writing an exponential function, basically that percent thing is almost like a giveaway. The only two letters you need to find are the A and the B. The B is always that percent. And that's not what I'm trying to teach you. Just reading through the big problem so that you know for this particular one, they give it to you right at the end. But he will not start making payments until he is done with his university work, which is usually about 6 months after. The fact that they tell you when you start paying back the loan, that's to fool you, to confuse you. So when you see this thing later and they say, oh, it's going to take about a few months to pay back, ignore that part when you're creating your equation. For your equation, you need to know how much you started with and how fast it's growing. All right, now see here. Alex decides that if the amount he owes ever gets to 35,000, this gets a little tricky. Now there are two numbers in here. You got the 30,000, you got the 35,000. When you write your equation, y equals why do I want to write it? I'll write it over here. Y equals ABX. The question is going to be, okay, am I using the 30 or am I using the 35? Well, let me ask it out loud. Anybody know how much this loan began with when you first started it? Yeah, it started with the 30. So usually, if there's a bigger number, it's still probably going to be the smaller number where the loan began, because it needs to grow to turn into that other thing. Again, this particular problem, I feel like it's going to be the hardest part of today. So once we get through this guy, then we'll, the other stuff should just ring a memory from before creating this, putting it in. For now, I'm not going to build this. I just want to say something about it. Where is it here? Let's see. If the loan gets to 35,000, it'll be too much for him to handle in monthly payments. Here it comes. If the function for the situation is P equals 30,000 times 1.045 raised to the T, they gave it to you. And you're lucky. So in this case, please highlight that. Do I have a highlighter? If I do, where are you? They won't always give it to you, but this one seems like they have. There you go. So I'm going to highlight the equation. How many months or years will it take for the amount owed to reach 35,000? That's what I was trying to get. If I have the equation, and ask me how long it's going to take to get to a brand new number. That problem looks a little something like this. This one here, first, T stands for time. Now, if we had to put this into our calculator, your calculator will not, let's find out. No, you can't get to P. Your calculator won't accept a P, and it won't accept a T, so if we had to put this in the calculator, we would put this as a Y and as an X the way we normally have. But for today's purposes, for this particular problem, they gave you the equation on the test, they won't give it to you. Problem number 1 and problem number 5. Problem number 1, you have to make up your own equation. Problem number 5, the very end, is where they're going to ask you to do what we're doing right now. So let's see if they're okay. Step 1, I'll write down the original, P equals the 30,000 times the 1.045 raised to the T power. We want to know what this stuff is going to equal when the P equals 35,000. That's what that big paragraph is asking. Now, when I write it this way, some of you should remember step 1. So I'm going to have you build it with me, or help me build it. Here it comes. Can someone say to solve this problem for T, what's the first thing that we're going to do? Change that P 35,000. Let me erase this guy to create some space. Step one is, and I wish I would have written in a different color. 35,000, replace the P. I'm going to write in all the steps so that it's there, just in case you ever need it again. All right, someone different. Hey, what's the first thing I'm going to try and get rid of on this side? What's the first thing I'm going to get rid of? Or what's the next step to do? Divide by 30,000. You know, I don't know if it's in here or in the other class. Someone divided by this 1.5 thing first, the 1.0, and then they did the 32nd. But it's true, when you try to get to the T, you got to get rid of the stuff that's furthest away first. Then the second. As a matter of fact, if I was saying a rhythm here, we're going to divide, divide, the end. Divide, divide, the end. Now here's the beauty of this. Because it's so fresh on your brain, we just did this as part of 4. Again, we could have gone all the way back to Unit 1, but I said, you know what, let me just back up to Unit 4. Let that do that particular step. Someone say out loud what that 35,000 divided by the 30,000 equals. 1.17. Anybody got any different numbers? That way I make sure. Is that 7 around it, or is that just working? If you did the 1.16, that number should be close enough where this time. All right, so let's see what we have here. I'm going to put this 1 point thing all the way over here just so it stays in line. And again, at this point, no one should be like, what? This is so crazy. I don't get this. You know, we did a million of these before. I'm only doing one of this one today. So if this particular problem messes with you, maybe it'll be the thing that's broken and needs to be fixed when it's time to fix it. If someone different who has an answer, tell me what I'm going to do next to get that T alone. Oh, hold on, I think you did answer. You did the first one. Yeah, I know. But still, and hopefully they'll know what you're about to say. Did someone else say it? Oh, maybe stop her. No one else picks it up. So both of you saying it together. And again, this will probably be the last time I get to say it, or last 1 or 2 times. Some other math teacher, if you told them, please divide that by the 1.5, they would say, no, that's incorrect. Now, I know it. I'm making it look like something you're used to so that it's nice and easy. Again, what did you say we have to put up there, Nick, on this side? Yeah. In order to do this weird kind of fake division problem, you have to put the logs. Officially, I'm not asking you to write this, just so if you're in another math class. Officially, what you were supposed to do is put log on this side. I'm going to erase it. You're supposed to put log on this side. And the extra step, you're supposed to bring the T all the way down in front. Because the log, all the log does is takes the exponent, brings it down, which leaves you with T times log. Then you divide this log on here and over here, and you're left with T and this division problem. So I decided, you know what, I can say that long thing, and some students get lost in that, like, or I can put the hyperlink, which is divide that red on both sides. And in order to do that, they have to write the word log, and they're winners. So let's find out. T equals, what does it come out to? 3.6 I hear? 3.56. Now the deal on this one, second. If you did, I would understand. But for the most part, I would do 2 digits after the decimal point as a general rule. So here's the deal. Because this is Unit 5 and they want to do a little bit more, they may ask, well, what does this answer even mean? Well, you probably get it in like, boop, boop, boop. There's a number, bang, now it's be done. Remember what the question was asking, and then someone say what this answer means.
It will take 4 years for it to go to.
You're right. And for our purposes, we'll make it years. There's a certain extra step you have to do at this months, which is whatever the T's, you have to divide it by 12. I don't want to add an extra thing. I like just this basic thing, and most teachers would do that. So this tells you how long, in years, for our purposes, it would take for your loan, because you didn't pay nothing on it, to go from 30,000, now you owe them 35,000. 3 years later. Call let's take a look at it. Step one on this one. For this dot thing, let's write in the, they have this raised out because they want it to be a times b raised to the x power. Normally you don't need that raised dot. It's not a point b, but it's a times b. All right, here we go. Let's read the question real fast. We'll build out the equation. I'll try this. I'm going to give you 2 minutes. Read the question. See if you can fill in the A, the B, I know where it goes, and then we'll do it together. And that way you'll know, okay, if I was able to do it on my own the very first time, oh shoot, I'm stuck. Population of flies increases at an annual rate of 22%. How many flies will there be in 5 years? The 5 years part is something I'm going to do with the calculator in just a moment. So we won't even do that one manually. Write an expression to represent the equivalent monthly population increase. Someone say out loud what the A is going to be. Yeah, that's where it started. Someone different. What will the B be? Yeah, that 1.22. And if you forgot, whoa, where's the 1 coming from? Of course, step 1, we turn the percent into a decimal, crossing out, and 1, 2, putting a decimal in front there. So this is kind of like 0.22. And again, for the purpose of increase, let me say the official rule. Technically, you do 1 plus whatever the percent is. In this case, 22. $1 plus 22 cents really is $1.22. Why is he showing us the plus sign this time? Because after this, I probably won't say it again. But what's true is if it increases, it's plus. If this were a decay or a decrease problem, you do 1 minus the 22. So you need to kind of refer to at least one time. Fortunately, they're only doing a lot of increases, and voila, there it is. Here's what I want us to do. And I may add some more. We may come back to this one. Yeah, we're probably going to sketch our stuff, but the new thing that you're going to have to do for creating the sketch, well, let's do this. Everybody, see if you remember how to make the sketch for this one. Let's say you were right on the side here. You're going to draw the airplane and put in the line set where it goes. See if you remember how to do that. The reason I want to do that first is because I'm going to have us create a table below it to answer that 5 years question. Okay. So draw that thing, see if you remember. Eventually we'll do the end behavior. If you remember that, you're basically done. So again, you put your plus sign there. I'm going to do mine while you're doing yours to show you that it doesn't have to be exact. Here, I know where my A is going to go. I know what it is. I know how I have to write it. Again, we just did this last unit, so I'm not teaching it like, oh, you never heard before. So I might go a little bit faster. If you were asked when I should do that, you might go a little fast. So here's what I want. What do we do about this 5 years thing? The 5 years thing kind of could work if you put it into the equation, but I'm not going to do it that way this time. I'm going to have us do a table. The x is the amount of time. So if we were doing a table, x and y, I think on the assessment they're going to say something like graph it for the first 5 years. So I'm going to put in a table just like that. The question is, hey, where am I going to get my numbers? This equation here, we haven't done a y equals in a long time. Do me a favor, into your calculators, please put a y equals with the equation that you created. The x is telling you what's happening in each year. The initial amount is when 0 is the x. Now, I'm going to come around to see your y equals. Once you get your y equals in there, the only part that should be tricky if you forgot is how to raise that 1.22 to the x power. But once you have it in, just raise your hand so I can come and look at your calculator. Because it's going to be the table that's going to tell us what's going to happen in 5 years. So that you'll hit your point. That's where you're y equals 100 times 1.22 raised to the x power. If you've forgotten how to get up there, you can ask. So here to fall. Oh, let's get you. Let's just pull it. That's weird. Right, we have to get the light, otherwise it won't give you that table. Yeah. Alright. Let me see. Alright, once you've shown it to me, then go to your table and fill in. Let's see it. If you have any trouble getting up that X, let me know. We'll get that thing up high. Go to your table. Alright. Move up the table. Alright, that part's very important. You'll have to do that. I know we haven't done that in a long time, so I just wanted to make sure everybody can. Oh, shit, I was walking around with the recording. Should have paused it. Nonetheless, let's see if I can get some numbers in there. Once you give a number, then don't answer again. What's the partner to the 0? Alright, thank you, Euro. Partner to the 1? 122. Is it just regular 122? Okay. Alright, you're out. To the 2, partner to the 2, please. 148. I'll put the 84. So what is this table's even telling me? What happens in the initial year? Where did it begin? At the end of the first year, how much was there? At the end of the second year, someone tell. Oh shoot, I'm not sure why I put a 4. Hopefully you have a 3 where yours should be. But tell me what's happening with the partner at the end of the third year. Someone do the end of the third year, please. 181.58. Someone tell me what's happening at the end of the fourth year. 221.53. 221.53. And someone that fifth year, which was the question. Put a star next to that last one, please. This is just a reminder again that if you know how to use your y equals, if ever they ask you for a year, you can just go table, and then on your x, that's the number of years, and then of course from there it comes across. A new thing. So this is one new thing that's in this last one that we didn't have to do last time. The second new thing is, please put time along the x-axis. When in any of these exponential problems, there will always be time. As time increases, the number of flies increase. On this side thing, whatever the thing is that they're talking about, this is a new thing. You'll have to label this. I wish I could get mine here. If I had thought about it earlier, I would have done it earlier. Okay. Flies is on the y-axis. If this were a loan problem, it'd be money on the y-axis. If this was a cow problem, it'd be the E. coli bacteria on the y-axis. So when you read the problem, you gotta know, okay, what's the thing that's going to be getting bigger? Is it the flies? Is it the money? What is it going to be? And that's going to be important to put it on there. Time will always be on the x. All right, let's see what we have on this thing. How many pieces do we have? They built the formula, step 1. They've asked to graph it for the first 5 years. For the graphing, you're just going to sketch the graph. It's the table that tells me that if they had to put in the exact numbers, they would be able to produce that. Okay, so the 0 and the 100, the 1 and 122 is going to get too hard. Then how would you graph 148.84? I'd say, you know what? Just show me the table. And I know if you had to do it, you could put those numbers in if they gave you nice, neat numbers. What's the next thing that they're going to ask you? They're going to ask you for the y-intercept. Please write down the y-intercept. It's no big deal if you know what you're looking for. You already have it on the picture. This is why after we build this one together, I'm going to have you build the cow one with all the new pieces on your own. We'll look at those pieces, and then there, most of us should be ready to go on the real deal. Someone say out loud what the y-intercept is, please. But for our purposes, they're going to make you write it as an ordered pair. So when you write in that y-intercept, they're going to ask you to write it as an ordered pair. Here's another new part. I probably should put stars on the new part. New part table. New part. What does the y-intercept represent in this context? Sure, I'll write it out. You'll write out this question. What does y-intercept represent in this context? This is the way I think they're going to write it. In this context. Anybody know what the y-intercept is? This problem. Right, and that phrase there is going to be important. Either the initial amount of flies, what it started out with. Sometimes some people write the original amount of the loan or flies. So for this purpose, I write the initial amount of flies. And I'm going to add a flies. Kind of gets it done. I'm going to put these brackets. I'm going to put is 100. Brackets, when you put those down, it's kind of like, you don't have to say it, but it's unspoken, but it's there. Sometimes it's added in. I mean, technically you don't need them, but everything that came before it should get the job done. What is whatever. The initial amount of the loan was. So that's how many flies you start out with in your fly collection. And if you have a fly collection, don't tell me because I think bad about stuff. Alright, so here's the cue. I mean, that's cool. That's cool. You'll be famous one day. So let's see what do we have here. We got the old. That's good. We got the old. That's good. We got the new. No big deal. Equation. Do button table. You're good to go. Y-intercept. Old. New is the initial amount. And here comes the last. Old and new. And that's what they want. They want to see, do you remember this? Here it comes. Last piece is end behavior. I'm running out of space. Hopefully you, I don't know how much space you use. Get that next page next to it and run out, you run out of space. Let's see if I can put in this end behavior thing so that you can graph any exponential function. You can say the end behavior, and then they're going to ask you what does the end behavior mean. I'm going to run out of space, so I'll have to move it up and down. End behavior, if you had a highlighter, I'd almost want you to do with the highlighter to cut it. You see, well, you cut in yellow. We've done this before. Let's see. As x goes to infinity, in other words, as time goes on, what is happening with the flies? It's going up. The y goes up. So again, the older version, as x goes to the right, positive infinity, which some people had put on here before. Too much information in a small space. As x goes to infinity, y also goes to infinity. As time increases, the number of flies increase, which is the new part. What does it mean? What does the end behavior mean in this context? That's what like we know you can write those symbols that you don't know what they mean because your teacher wrote them 100 times and you can bang, 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 bang. Then they're going to ask you now, hey, what does your stuff mean? I'm going to do this positive side and then tell you why we're not going to do it. I'm going to ask you why we're not going to do the negative side in terms of writing out what it means. So let me see if I can do it this way. Let's write out the negative side, the blue stuff that you're used to. But we're only going to write As x backs up to negative infinity, let's see if anyone remembers, what is going to happen to the y? 0, and it's because of this line here that the graph approaches but never touches. Anybody know the name of that guy? Asymptote is the name of that guy. But it's the green that has meaning. Why doesn't the blue have any meaning? Because it's negative. You can't have like a negative rats, flies, and negative time. It just doesn't make any sense. So it's usually the positive side. That would make sense. In terms of the new has this part here. New with a star. What does this mean in this context? The end behavior, which I should have written end behavior, now I'm out of space. Yeah, that's too much. Barely readable. As time increases, the number of flies in this case increase. The amount of the loan increase of his money. What else? The number of E. coli bacteria increase. In other words, you have to go back and read whatever the topic was when you answer this. As time increases, the amount of flies increases. The amount of something increases. The amount of flies increases. Look and see if any questions you can ask about this version. I'm going to give you the handout for the count problem, which you're familiar with. And I'll already do the count if you already know that one. So that the pieces you already know, bling, 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 those go in fast. The new 3 pieces table. What does the y-intercept mean? What does the end behavior mean? Those are the parts that I want you to think about. The other part I don't really want you thinking about. But pause, take a look at this. Are there any pieces here that you may want to ask about? At least in this last part. One quick note for somebody, you know, memorize this, just have heard it once. Let's imagine we drew this picture here, and it looks something like that. That's the graph. The end behavior on this one would say something like, it needs to go through. As time increases, the amount of uranium decreases, usually with nuclear fission. But the point I just want to make, they could give you a different picture. And you have to put in the end behavior, but just know that you just write as it decreases. So does the, as time increases, time is always getting bigger. The other one decreases. Alright, so again, the initial amount is that 5 billion, which goes there. The A, for those who've forgotten how to cross that over, because I know the last one is 0.22, so some may have put 1.32 without that extra 0. Just remember that when you're changing that guy, cross out, wherever the decimal is, 1, 2, and if there's an extra space, you fill it in with a 0 to give you that guy. So be careful with that. You add the 1 in front, and now you have that 1.032, no big deal. There's no picture drawn from there, of course. The end behavior, the same thing, the 2 arrows. I didn't chop it, I guess I could. And so, of course, we have our end behavior. The 2 new pieces I need to write what it means, and then I'm asking to help me with the table, and then I'll let that one go. After that, what will happen is we'll just do the formula for one of the pages so it can kind of help out with the whole 6 pages thing. I'll remind you of that original problem we did at the very beginning, that 35,000. And then from there, I feel like enough people will be ready to go. Those who aren't, do what you can, and we'll fix what's broken in the future. So here it goes. So what am I adding in? So just out loud, what does the y-intercept represent in this problem? Yeah, and that E. coli bacteria is important. Because then the y-intercept is always going to be the initial amount. original amount, initial amount of this, in this case, of what I was trying to think to see if I was just thinking that there were 5 billion E. coli bacteria initially. I was trying to think, should I say that, or is it enough just to say that the wine set is the initial amount of E. coli bacteria? E. coli bacteria. All right. And someone else, what was the end behavior? What does it mean? The green side. That's a good statement. To make it match kind of how we said it before, I would say, that's what I have to do. I wish I'd said, please put time on that guy there. That part is the new part that we don't remember. Even I didn't remember because we didn't do it. If this is time, what is the Y on this one? The E. coli. Alright, that part no one should have. I didn't think of telling you bacteria. This part here, I'm reminding you now, write time on the official thing when you get it. Because if you don't, then it makes this last part tricky to answer, which is as time increases, what is also going to increase? E. coli. So does E. coli bacteria. So does. If you wrote yours in such a way that it kind of means the same thing, you don't have to erase yours and rewrite it exactly like mine. But this is kind of the way. So does E. coli. See, right now at Unit 5, they're like, okay, they can do the moves, but do they even know kind of what it meant? We didn't stress it. I didn't stress it so much before because it's like, okay, let them get the moves first. Now we know. And then the last part is my table, which someone can help me with. Let's see if I can do this. 1, 2, 3, 4. 1, 2, 3, 4. 5. On the way the question may say is, hey, what's happened in the first 5 years? Which makes you think, okay, 1, 2, 3, 4, 5. Somebody might go, isn't it 6 that you have? Because that's 0, like 1, 2, 3, 4. Well, 0, of course, is where it began. But that initial moment. At 1, that's the end of the first year that we have there. All right, partner next to the 5, next to the 0, please. 5 next to the 1. 5.16 next to the 2, please. 33. Someone else next to the 3, please. 5 by who? Yeah. Hopefully you can see why, again, when they say graph the first 5 years, I'm going to take the table. Because if you have to graph 5.16, 5.33, how are you scaling this thing here? Are you making it 5, 5.1, 5. I mean, how are you scaling it? So the idea is like, the fact that I see this, if they had to do it, they have numbers to use, 1 and 5. 2, and, so this is me making it easy on you and on me. What's the partner to 4, please? 6, 7, and then what happened in the 5th year? 5.85. I'm going to put a star there because I think it's the 5th year that they care about. If they actually find out what happened in the 150th year, yeah, it's true, you could scroll down. But technically what I would have you do is you would type in the original and then just put a 150 in place of X. So when the numbers are low, put in the original, go table, and find the partner. If the numbers get too big, then it doesn't make any sense. In the place of X, you actually choose a number that you want it to be, and then go from there. All right, pause. The last time for the big part, we're going to do a little part, and then test. On the big part, is there any piece in there that anybody's wondering about, thinking about? Where'd you get this? Where'd you get that? Do I have to write out the whole thing, Golai, as yeah, you have to write that? Will I get it wrong if I forget to put time and the thing? No, but it will probably mess up something down here, which will when it's time to fix it, you be like, and I'll say, hey, did you get to write something along the x-axis? And you'll say, no, I didn't. All right, now, how do you want to do it? All right, so here we go. The last two pieces of the puzzle. One, have you build the equation on a particular problem, see if this decoy number throws you off, because it's going to throw in a decoy, and then after that, then I do the big log problem. Okay, I'm going to offer to you. All right, where do I want them to go? You don't have to do the whole problem. Just setting up the equation. I just want to see if the numbers and all the paragraph they give you will throw you off. And that is 64. Pretend 64 where it's at. For the purpose of 6 pages, once we get our equations, we'll probably sketch it a little bit. But for now, what is it that he really wants? He wants to see, can you write in the equation y with ABX? Beat that problem. Let's see what you choose. It's test like. So if you choose the right thing, hooray. If you don't, I'm going to say it. Even if I'll take it. Of the last two things we're doing, before you get your assessment, this is one. The other one. Now it is. Thank you for coming. Your bucket's almost full. I was able to help you fill your bucket. That means when you become rich and famous, like, yeah. Don't all those words scare you? Write the equation y equals ABX, choosing the right A, the right B. And hopefully the decoy number doesn't mess with you. Okay, this one is just and build these particulars so that you can understand whatever. And that's why the last piece of the problem is good question. Just peeking on this one, write down a y equals ABX, even if you're guessing, it's okay, because the only three numbers you get to guess about is the scenario that it's be okay. If you get trying to get a final answer or anything like that, not required. This is just make sure you see this picture number. Will it throw them off? Will they go for the decoy? I saw a lot of good stuff out there. So here it comes. Big long problem. My little friend is taking out a college loan. Loan means money. The original amount she took out was that 20 grand. She wants to start paying back for 6 months. Hooray, good for her. But the minute you have the initial amount, you know your B is always at percent, guys. So good job on not being thrown off by that. Graph the function showing at least 5 years. That's the way they're saying it there, is that whole idea of table. Now, I'm not asking you to do that part here necessarily right now. I just want to get this part here to see, would anybody go for the 6 that was in there? I don't think I saw it, but even if you did, that's fine. It's 1.12. I see it's 0.042 on that guy. So if you have this guy written on the board, good job to you. What else do I want them to know? The 5 years part they get on the table. I want to back up to the fly one for a second before I say the last thing and then offer to you. But pause. Anybody want to ask anything about this? I saw a lot of good stuff out there. It's true. Eventually, if you create this part of your 6 pages, it would you do your picture going up still. I don't know why they cut off all this extra part. You need the airplane taken off for a little bit, but that's fine. Let me back up to the fly because I think I saw it on 2 pages, which makes sense. But let me say something so that I can say something about the fly, say something about the 30,000, and let you take care of business. I know. I want to be in a math class too. I really just do with the people. All right, so here goes. What page is the fly problem? So I'll get back to that. Some of these pages, see that domain and range stuff? That domain and range stuff's going to come back again. Let's say you're a fly. You are a fly. All right. What does he want to say about the fly thing? Does he want to do any work on that page? So here's what he wants to say. Some people mess around because of that 5 that they threw in there. They messed around and maybe tried to put a 5 in place of the y to solve it. The trick is this. How do you know when you're going to put that y thing in, like we did with 35,000? You could ask the question, how many years will it take to get to a certain number of flies? Like, how many years will it take to get to 122 flies? Then you know you're putting that 120, oh, bad, I'm not using 122 because it's that. To get to 120 flies, you put in your 120 over here, and then you do that work. If they say, what's going to happen in 5 years, you don't get to do anything. Years is this little X floating up here. So the only way you'll know to put in a new number here is if they say, how many years will it take to get to blank, 120, 35,000, whatever the number is. The good news is, the very last problem is the one that's going to ask that question. So everything else is going to be the stuff you just did. And the very last problem will say, how many years to put it. I'm kind of guiding you a little bit more than probably I should, but it's the end. So last thing he wants to say to them, and then give them 2 minutes to clear their brains, and then the assessment. What page was that 35,000 question? Is it 50? There it is. I just want to read that part. Comment on the stuff one last time. Give you 2 minutes to clear your brain, and then off to you. How many there is? How many months or years? How many years will it take for the amount to go turn into a new number? Plug it in. Plug it in. Divide, divide. For those who are really shaking these, plug it in. Divide, divide. That's your little thing in your brain. Divide, divide. Divide that original 30,000. Dang it. And then divide again. Divide that last number about installed. Plug it in. Divide, divide. Alright, clear your calculators. Take up your notes for 1 full minute, or don't. Let your brain just relax 1 full minute. When you get your screen. I'm trying to make it bigger, but it's not good. Actually, most, not all of you, if you got into an exponential function, will be able to. So you kind of highlights that they're going to make it look long. 2-page problem. For some of you, make you more comfortable, so I'll give you an option. The y-intercept, the end behavior, they all want it on the back. They just want the equation and the graph in the front at the table. But what I'll say to you is, since we kind of do it all together, for those who want to do all their answers on the front and then fill them in on the back, you can. In other words, if you're used to putting the y-intercept on the front and the end behavior on the front with all the arrows and all that, you can do it all on the front. And then when you get to the back, you can put it into the slot by slot.
If we don't have the arrows on the graph,
No, that arrow thing, you should be okay. It's just a proof to me that you know, okay, in 20 seconds, we'll start handing out. So relax. table will go next to the graph. Name, class, color. Again, you can look on the back initially if you want to just see how they ask questions on the back. Get down to the end. Back of the page 6. The table of contents of the graph. how to do it. You can do it now. It's the very first thing we did in our class. Second, 4 unit. Okay. Wash. I remember that I wanted to do something with the
Oh yeah, yeah,
so
yeah.
just
Okay, I can go back.